you to know any, like I said, no specifics about which arrows are doing what, but you should know that, this is, which part is what. You should know this is the proximal tubule, and this is up here in the glomerulus, right? So this fits over here, and you've got some capillaries, so you can do some exchange, and then this tube is where eventually the urea goes down into the ureters, and then the bladder, and then the urethra, and then out. So what remains in this tube at the end of the collecting tubule is what's leaving. Everything, all these other arrows, if the arrow is going in this direction, it means it's going back into the system. So we start here in the cortex, and then if you think about the kidney, if we think of it as our kidney bean-shaped item, the cortex is kind of the outside, the medulla is the middle, so they're traveling through the outer and the inner medulla. So you're going out, and then you travel down here, and you've got the descending, which is going down, and then the ascending going up, loop of Henle, and then this is the Dinlin. And then going through, you've got the distal convoluted tubule, which goes to about here, and then you go down through the collecting tubule. So I will not ask you to draw this, I will not ask you to identify, it's not anatomy and physiology, but if you can think in your brain that this is what's happening, this tube is weaving around, and it's sending ions out, and it's bringing them back in, so that at the end, this filtrate is going down to be urine to be removed, and this is what's going to be put back into the bloodstream eventually. That's good to know. Okay, so notice here where it says 0.5 to 5% remains, that's that 95 to 98%. We are taking back in 95 to 98% of all, I mean really 99.5, but that's sort of on the outer end, of all of these things. So we send them all out into this urine, and then we go back and forth, and then we concentrate it and send it back. So 95 to 98% is coming back, even though we go through this long process. And the reason that we go through the long process, the reason we've evolved, is because we're working on concentration gradients. A lot of times, so we have some active processes where we can send things out into the urine, but a lot of times we're driving. When we go back, if you look back at the board, there are 9 potassiums over here and 1 over here. We're creating concentration gradients in a part of the fluid outside, say the descending loop of Henle, so that things flow in the direction that we want. And then we create another concentration gradient to send them in a different direction. And then another concentration gradient to send them in a different direction. We do some active transport, and we do some activation of channels to increase or decrease the relative flow, so that at the end, we've stayed in homeostasis, and our urine can be more or less concentrated depending on our conditions. But that's why we send things out and bring them back. There's no determinism. It seems like kind of an inefficient system, so who knows why it actually evolved this way, but that's the function. Concentration gradients back and forth.